in today's world of kind of open science and public data. With JWST, there were a lot of programs that were approved prior to the telescope even launching into space. And some of those programs were called early release science programs. Those programs were meant to test capabilities of the telescope. And in exchange, we were some of the first teams to get data, but that data was immediately public and available to anyone, not just those of us who proposed for it. There are different programs that have proprietary time. So those data are only visible to those who proposed for it for up to 12 months. But there are large programs. There are different kinds of observing programs that have been proposed that were immediately released to the public. So anyone who is interested really can kind of download the data from the archive and take a look at it. And like as soon as we do as well. So
yeah, but it hasn't even been around for a year, right? How is there data that you're waiting on that's not available yet?
Yeah. So the telescope started taking data for science purposes about last June of 2022. The first data release was with the image releases that NASA did in July. So mid-July was when the data actually finally was no longer embargoed and was released to the scientists and, well, some of the images to the public as well. And so it has been a year since the first data release. So anything that was taken then and was not public immediately already is. But the telescope is taking data every single day. And so it kind of staggers. So if something is taken today with a proprietary period, it has a year, then we won't be able to access that unless we were on that proposal until, next October or so. But the data that was taken in the first year, so to speak, is starting to become public as we go through. And right now is an interesting time to be talking about this because we're in the middle of the third cycle of proposal call. So we're proposing for time on the telescope. This is a third call for proposals, and those are all due in like 3 days, 5 days. I don't know, but time it is. And those will be for observations that start, next July. And so it kind of just keeps going in kind of incremental yearly cycles of proposals and observations.
Right. But what data is available that you have looked at that has been useful to you and why?
Yeah. So personally, I've been focusing predominantly on a program called the Cosmic Evolution Early Release Science Program, or CEERS, CEERS. And that data was public immediately once it was taken. We had data that was taken in July or June and released in July of last year. And then the second half of our data was taken in December of last year. We had a few that were the telescope did something strange and so got retaken again in February. And then we had some other data taken in March. And so all of these data sets were public immediately. So they were available to everyone at the time. In my particular case, we have imaging. So images of this, what would look like to your own eyes, a blank spot in the sky that has thousands and thousands and thousands of galaxies in it. When we get the images with JWST, we've released a public image for anyone to take a look at. That is a color image where we've taken all of the different wavelengths that we've observed, put them into different colors, and then combined them so it's a color image of this field of galaxies, which you can find if you would like to look it up. It's the CEERS field, again, CEERS. NASA did a press release a couple months ago with the full color image of our survey field. And if you have a computer, please don't download it on your phone. The file is really large. You can download the image and you can look through it and just keep zooming in because there are so many galaxies. And if you just keep going and zooming in, and there's more and more things for you to find, and you can definitely get lost in that space with us. These images are of a field, a spot on the sky that we've studied extensively with the Hubble Space Telescope and many other telescopes prior to JWST. And so we had specific things that we were targeting, that we really wanted to look at this particular galaxy or that particular galaxy because we knew about them already. And one of the science cases for our program was to look at some of these galaxies that were very early on in the universe, which we had discovered with Hubble. I spent many years on one of the largest observatories on the ground, the Keck Observatory, trying to obtain spectra or very discrete data from these galaxies to measure their distances very accurately and understand their properties. And so some of the sources that we were observing with this program, we got images of, but we also got spectra. And so with those spectra, we're able to actually see the different elements that existed in these galaxies and how abundant one is versus another. We're able to see kind of from that, the elements that are there, that we can determine what kinds of stars existed. We can understand a lot about the actual processes that are physically happening inside these galaxies that existed over 13 billion years ago. And in my particular case, one of my recent discoveries and what I've used JWST to find was a very distant, and at the time most distant, active black hole at the center of this galaxy based on the spectra we got with JWST.